Hello, beautiful people. Welcome to 3.4, Solving Multi-Step Inequalities. These were the results from the warm-up that we did earlier, so if you didn't get that, make sure you press pause and check your work there. Our swap at for today is to solve, graph, and write linear inequalities. So let's begin. Solve the equation and graph the solution. So we're pretty much just going to treat each inequality symbol the same way that we would an equal sign, except remember, when you multiply or divide by a negative number, we flip the arrow. So let's begin. For this one, I'm going to add 7 to both sides, and I have negative 4x is less than 20. Then I'll divide by negative 4, and then I have x is, I divided by a negative sign, so now greater than negative 5. Greater than negative 5. Phase 2, now that I've solved that, I'm going to go ahead and place negative 5 kind of in the middle. And then if this is negative 5, I would go negative 4, negative 3, negative 2, negative 1. This would be 0, negative 5, 6, 7, 8, 9, 10. Give me just a couple, one on the left, one on the right, and then we're good. So because this is strictly greater than, I'm going to have an open circle at negative 5, and my variables on the left. So because I want the values that are greater than, I'm going to shade everything to the right, to the right, to the right. There you go. All right, let's continue. Not a big difference. The only thing is we have like one more step to do from when we did 3-2 and 3-3. Now, for this one, before I do anything else, I'm going to want to simplify as much as I can. So I'm going to distribute. 3 times j is 3j. 3 times 1 plus 3 less than 3j, and then I'm going to go ahead and combine these. 3 minus 5 is negative 2. I'm going to collect my variables, so minus 3j, minus 3j. These cancel out, and I have 3 is less than, wait a minute, these cancel out, negative 2. This statement is saying 3 is less than negative 2. True or false? Never, ever, ever, ever true. So I'm going to say no solution. That's never going to happen. There's no solution that will ever make that true. Okay, if you'd like to, you can press pause and try number 3 and then fast forward through me. Or you can join me and get negative 6. Just kidding, that looks like a 3, doesn't it? Negative 6n plus 3 is greater than or equal to, now this is the 1, and then I'm going to combine these two terms right here. So negative 5n minus 3n is negative 8n. And I want to collect my variables again, so I'm going to add 8n to both sides because I have n's like all over the place. I want them all together. So this gives me 2n, negative 6 plus 8, plus 3 greater than 1 or equal to 1. I'll subtract 3 on both sides and get 2n is greater than or equal to negative 2. Divide by 2. These cancel. N is greater than or equal to negative 1. Now, just as a side note, over here, if I had something that was true, like if instead this said negative 2 is less than 3, that's true, always. So for that one, I would say all real numbers. All real numbers. It's not true though, so no solution. But if you do get a statement that is true, then you can just write it like that instead. Okay, what's next, beautiful people? Translate the verbal phrase into an inequality, then solve the inequality and graph your solution. So let's translate twice the sum. Well, I see twice and I think 2 times. So twice the sum of x. So sum means addition, and I'm adding x plus 8. So 2 times the sum of x and 8 is greater than or equal to. So greater than is always to the right, or equal to. Greater than or equal to negative 36. Take a moment, beautiful people, and press pause if you don't mind, and solve this for me. Do it, do it, do it. Bam! Just like that. I got x is greater than or equal to negative 26. Greater than or equal to negative 26. Now notice here, I did not switch my sign. Now some of you might need to press pause right now to copy down my work. But I didn't flip my arrow because I didn't multiply or divide by a negative number. So I'm going to go for about the middle, which is about here, 26. And then just give me a little bit of a cue. So 26, 25, 24, 23, 22, 21, negative 21. And then let's go the other way as well. 27, 28, 29, 30, 31. I just need a couple points that show me that you do actually know how to graph these. Open or closed at negative 26. If you said closed, you are correct because it's equal to. So I'm going to have a closed circle there. And then it's everything greater than negative 26. So that's everything greater than, to the right, one more time. There you go. And if you can't see it, this is not a bad lesson to go ahead and have a highlighter so you can highlight your answer. Like it, love it, great. Okay, lastly, problem solving. Bum, bum, bum. A water park, ooh, let's zoom in just a little bit. Bam. A water park charges $12 for admissions. That seems important. I do have a highlighter, so let me go ahead and use it. $12 for admissions and $5 to park my car. That's kind of cheap nowadays. Write an inequality that represents the possible number of people. So already x equals number of people that could go for $50. Assume, guys, that we're only taking one car. And the question is, what is the maximum number of people that can go? All right, so here is what I think is going to be a good one. I'm going to spend $12 for each person. So that's $12 for every person, but I don't know how many people I'm taking, so I'm going to put X. Plus, I'm going to pay to park my vehicle. If there's a lot of us, maybe we just take a big old van. Now my budget, though, is $50. So this is how much I'm spending. It could be equal to $50. That would be great. But the question is, can it be greater than? Nah, because we'll be embarrassed. We'll be at the line, we'll be ready to pay, and then somebody will not be able to get in. So this amount has to be less than or equal to $50, because I don't want to be that person that says, sorry, you're going to have to wait in the car. So then we solve this. I think you can. This is my inequality. And if you press pause, you can do this, or you can join me. Less than or equal to 45 divided by 12. Well, that's a bummer. This does not go in evenly. This is about, if I reduce it, divide by 3, I have 5 over 4, also known as 15 over 4. So this is about 3 3/4. Well, they're not going to charge me by 3/4 of a person, and no matter how short your short friend is, they're still going to charge it for a whole person. So let's round to the nearest whole person. Would this be, can 3 people go or can 4 people go with 3 3/4? Well, if you said 4, that's that one person that's going to be stuck in the car waiting while everybody else has fun. The maximum number of people that can go, the max number of people that can go is 3, because at 4 we don't have enough money for 4 people, which is fine. We're just going to go, the 3 of us will all sit comfortably in the car, and we'll have a little bit of extra money to buy maybe some drinks or a popcorn or something like that. All right, beautiful people, that's my lesson for the day. I hope that you enjoyed it, and I'll see you next time.